I do not know. Okay, that's it. So, we have a star. But the thing is that it's very massive. Yep, it's very massive. So, you gotta... this thing just means it's gonna explode. Let's see. But this also has... Oh, it doesn't move. Alright, so here we have some Q. Some hydrogen. They're really hot. And for... I mean, they're kind of hot, but just hot enough to fuse into some helium as always. Like, they gotta fuse at some point. The star is pretty normal still, because that's how it is. That's just how it is. But eventually, helium just kind of skyrockets everywhere, and hydrogen supplies are starting to run lower. Unfortunately, for such a situation, things start going downhill. The star starts turning into a... The star starts to swell more. Starts to swell a bit more into a blue supergiant from a blue giant. This just means that it works harder to do it now. And this is just a transitional phase to wait until once it gets low. Once it gets low into a critical point, this thing expands rapidly, turning into a yellow supergiant. Nobody likes that, you know. And then not long after, this transition goes to its final form, a red supergiant. That's not it though, because in the red supergiant phase, as helium runs out during red supergiant phase. That's unfortunate. Quickly, and then, but during the thing is that there's still some hydrogen, but it's not really enough, you know. They're too dispersed. You can still make some fusion, but you need to get something else as a substitute, because this won't even last a year or two. Like, seriously, these things can last for millions of years, even this type big star. So if I have to say it, it's gonna fuse carbon. Carbon happens. Carbon is pretty just a chill paste thingy. Thing is that it's not like a tree by, you know. Helium just fuses into carbon, you know. And then suddenly things start getting hotter. Suddenly, the star collapses into a smaller star, less than its mass rapidly. This is a naked helium star, and the reason it's called a naked helium star is because it you see, it kind of lost a lot of mass. It's like taking off your clothes, but the thing is that you have a lot of clothes. Maybe even took off your skin and muscles for this one. Forgot how much mass it lost, not just your clothes. So this is like naked. in a human perspective, so it's not a fusion environment. Once helium starts running low to create carbon now. Now things start doing only what high mass stars can. Like B and O stars are high mass stars using carbon. The moment you start fusing, once you start fusing carbon, the stars transition again. But however, you can directly fuse into oxygen or with some of the, because it's not very hot enough to do that yet, but you can still fuse that. You can still do that and create magnesium, and you can just create a bunch of a lot of other materials. Now there's just sphere because I'm just lazy. I don't want to write all the molecules inside of it. Just basically a lot of new things happen. I don't want to list them all. That's it. And thus the star starts turning into an, what do I call them? Daniel type stars.
Where the hell is my another food? Oh, you find my black lady?
No.
Too much thing you put in my bag.
Okay.
Why can't you bring your own bag?
Just shut up, please. Okay, so now this thing turns into a very purple star now. This is, it's the color of Daniel star. This thing is really, really hot, so please. In this time, fusion kind of just accelerates. This is a roof riot star, and things are not going so great because this thing only lasts so short now. Now, quickly after it fuses, oxygen. Just rapidly slips up everything out. All other materials just get dwarfed by this. And because of the abundance of oxygen, now the star becomes very unstable, more unstable than ever, creating extreme bursts, and now it's starting to pulsate. A bit, every once in a while. This is kind of a late Daniel star. Sure what is after Daniel 2R, but now iron starts filling up, and when there's iron, things get attacked for the worst, like literally. Like iron is not good for the star because it can't fuse. So the star starts to shrink slightly. The temperature increases highly and as it compresses. However, this pulsates it stronger. But then it just starts to weaken a bit. It gets smaller, pulsating smaller and smaller and smaller until it just kind of, supernova itself. This is when most of your core is now iron now. So if you want to know how this is, it's basically that your core is already mostly iron, and yeah, there's still some material should be used to fuse, but I mean the oxygen rapidly turn into silicon and then iron. Hey, this is not going right. But most of the fuels are ready. Iron, and the remaining fuel is not enough to fuse to support the star now. A tipping point creates the supernova. See ya, guys. Ready or start. So this is where silicon is fusing, and it fuses. If you know this, this star is it fuses very fast. It fuses a lot of material, but once it starts creating iron, it starts pulsating. Okay, see ya.